So thank you and welcome. Can everybody hear me well? Yes? Okay, perfect. So we are just taking the time machine and we are getting back to the 80s. And this is actually a personal trip that I want you to accompany me. Why back to the 80s? Because that's when I learned to develop. I was a teenager back then. And all of a sudden, I realized that I could tell machines that to do what I wanted them to do. And it was like, it was a great feeling that probably most of you have experienced as well, and probably when you were teenagers, even younger than me, because when you were younger, computers were here. When I was younger, computers were not in Spain. So it was a great experience. That was 30 years ago now, and a lot of things have happened in these 30 years in my life. Most of it has been great. I got my computer science degree. I joined a multinational company, but I spent 25 years working in a non-technical environment. So let's say that I became a little bit rusty with technology and especially developing. So I knew it wasn't me. I was really good at algorithms, but I was totally obsolete. So last year I was reading a blog and I found out that in the States, Amazon had launched the Amazon Echo, and that is like an ambient speaker that you have at home, and it picks up voice. You can give it instructions basically, and it can do stuff for you. So it's like a different way of running a user interface. And I thought, this is really cool. So I kept on reading about this, and I saw that these guys had opened the platform, that you could try it out. And I thought, this is fun. So I took some time, started looking at that, and it just came back to me. I had that thing at home. I was able to run and create programs, and that thing was listening to me, and it was doing what I wanted. So I just got hooked again, and I thought, wow, this is like going back to the 80s for me. So that's why I wanted you to just go on this little trip with me. So what we will cover is a little introduction, because this is a brand new way of exposing our systems to users. We will see it not so brand new, because voice services have been around for a while, but this thing is going to explode. This thing is going to come to all the markets, and it will be a little bit like when the smartphone was launched, that we forgot about these things, laptops, we use them for work, but when we want connectivity, we want to communicate, we just get our smartphone and do stuff. I believe it's going to be like that. I believe that this is the time that ambient computing, pervasive computing is going to go boom. So I think this is the moment for us to start just getting knowledge on this, because it's going to have huge opportunities for us to work on this brand new of doing things. There is this warning. I have said it before, I'm very rusty. Probably you guys are way better than me at the things I'm going to talk about. I'm not a junior developer, I'm a junior developer, so bear with me and we will be fine. So introduction, history. That was the first voice services ever, the switchboard operator. That image is from the first decade of last century. And well, you know how it is. In cities like Barcelona, maybe we had like 500 telephones in total. So we had like a couple of ladies just receiving calls and then just changing cables, because rich person number one wanted to speak with rich person number two, and then they just switched the cables. And we were engaging these operators via voice, so she was the first one. Then in the 80s, interactive voice response systems appeared. And this is the typical thing that we all hate. Press 1 for your reservation. Press 2 for the status of your flight, etc., etc. It really drives us crazy. But it was implemented in the 80s. You guys were all very young, but that's when it started. Then in the 90s, companies like Nuance, previously known as Dragon Dictate, they started to create voice services, creating neural networks, training algorithms. You could create very specific and very expensive software that would use voice. That was something that happened in some hospitals in the States, in operating theaters, for instance, with surgeons that get paid a lot of money, and they cannot use their fingers to use a keyboard while they are operating on a person. But that was very specific. And this century, about 7 years ago, voice services just went boom. Voice services, difference between voice services and the previous one, scale. This is going to go into millions and millions of homes, and it's in millions, gazillions of pockets, because we all have an iPhone or an Android, so we have Google Now, or we have Siri, so this is already big. It's cloud-based, and it's served as a service, so voice services. But nowadays, the system that is used the most in commercial purposes is a mix. So typically what happens is that first you start with an interactive voice response system in which you say if you want one for the reservation or second for the status of your flight. Then the system will ask you to say something. So what is it that you want with your reservation? And there will be some kind of intelligent system that will pick up. And then it will just derive you to an operator. So we have the three first layers is what is active up till now. But now we will see a breakthrough, and we will get more and more voice services which are 100% machine serviced. Okay, so voice services timeline. The first big company that just got ambient computing working and in millions of homes was Microsoft. Nobody thinks about this, but Microsoft Kinect. You have console, you will know that. That's when you could do the dancing without holding a Wii remote control, and it would detect your movement. It also had speech recognition, so you could switch on the television and switch it off speaking. And that's why voice services, we say that they started in 2010. Then Apple launched Siri shortly afterwards, and it was a big revolution. It was very funny. We were all asking silly questions to Siri, and sometimes the answers were quite funny. And it's becoming more and more useful. So we are using it a little bit more. Google followed, Google Now. So, okay, Google, ask a question. Again, it's getting better. And then, sorry? Okay. And then Amazon just was doing nothing. It was not in this space. And they did something unique, which is the Amazon Echo. So all of a sudden, nobody knew they were working on this, and then they had a household device. You could buy it, and you could just use it at home. And they have sold, the first year, they sold like 7 million devices in the States alone. Then Google Home is catching up. They have recently presented the Google Home device, and they have opened also the APIs and the SDK so that developers can start creating systems for Google Home as well. And finally, when I say Lex, I will talk about Lex a little bit more, but Lex is the intelligence inside Alexa. So basically, it's all the machine learnings, the natural voice recognition algorithms, the speech synthesizers that Amazon is putting together, and they call it Lex, and they are trying to package it and also sell it as a service. We will also see it a little bit. So this is about voice services. This is not about Amazon, but I chose Amazon as my toolkit to experiment with this. Then the reasons why I selected Amazon, one of them was that I was reading that magazine and I heard about the Amazon Echo, so it was the first one, okay. But there are more reasons. The first one is that they were very open about releasing it and giving tools for developers so that we would start using it and creating skills, creating applications. That was very, very important in my opinion. At the time, Google was already working on their technology, but it was totally closed, only for senior people, people connected with them, partners, etc. It wasn't so open. That's something that I liked. Then, in my experience, it's not quite easy. It's possible to disentangle your logic. So you can create your system, and you can clearly put some lines, some barriers. Where is my functionality that I can take to other providers or I can reuse? And what is specific for Amazon? And I have a lock-in effect, and there is no way I can escape from Amazon. I need to be with Amazon. I think it's quite easy to disentangle. That's another big reason. And again, the resources they put, the forums, for instance, they give a lot of love to this, to the community. So it was nice. And also, the fact that you can do a lot of things with examples and through the console means that the barrier of entry is not so high. If you have the chance to get into creating applications with Google now, you will see that the barrier of entry is slightly higher. It's not like you log onto the developer console on your web browser and you can start to do stuff. You need to install things on your machine, which may not be rocket science, but it's more professional, let's say. You can do equally professional things on the Amazon platform, but it's easier if you are not senior developer. Okay, ambient computing, that means that you have a loudspeaker in the middle of your house that is listening to you all the time. We have to talk about privacy. There is no way we can escape this debate. And especially nowadays, because if you read the press in the States, that was in the news everywhere, there was this guy in Arkansas in the States, and he had an Amazon Echo. I'm using the past tense because he was killed at home. So for the trial, the jury or the attorney, they wanted Amazon to disclose all the recordings and all the information about the activity of that Amazon Echo device in the evening that this poor guy was killed. Now, Amazon know that this is in the news. And if they now very easily give this information away to the authorities, that we will all have the perception that they are listening to us and that we are being spied and that there is no privacy. And this is actually the case. So what they are doing is they have a lot of lawyers and they are trying to use the First Amendment in the United States to fight off this request from the authorities. We know a little bit what is going on with our information that is recorded through voice services in Amazon Echo. And this is what we know. We know that Amazon is constantly listening. Otherwise, there is no way for them to know that we want to use the service. But they are not storing everything. They only store 60 seconds. So today, if I had an Echo now, it would be storing me speaking, and after 60 seconds, it will just delete that buffer and start recording another 60 seconds again. So they say that they are only in your privacy for 60 seconds at the time. This is what they say. But, for instance, I'm not American, and I'm not English, and I have a strong Inigo Montoya, you killed my father, prepare to die accent, if you know that movie. So I have my Amazon Echo set in a way that it stores my voice so that I can train the Echo to know that I'm not an American citizen. My accent is quite strong and for Echo to understand me. But I can opt out of that. So in my case, I know Amazon knows everything that happens on my place. Well, something else is that every time you use a service, for instance, in Spain, it's not so useful, but in the States, you can get your Pizza Hut, you can get your Uber, you can do a lot of things with Amazon Echo already. Amazon is tracking all your transactions, of course. Finally, you can access all this information. They have a smartphone application for Alexa, so you can see exactly what they have about you. So they know a lot of things. Will we get used to it? As some people say, I don't think that this is a good thing to go about. Privacy is important. At least we should know what's going on, and we should make our own mind what we want to do with these new technologies. Okay, so enough about the introduction. Now we are going to get into voice services, what components they have, how do we make a voice service, and we will take a little trip to the 80s. So if you only have to remember one thing from my speech, it's that one. Don't frustrate the human. Don't frustrate the human. Why? We all know it. We are trying to interact with a company, Endesa, Telefonica, any company, on the phone, and we get the automatic system and we get so frustrated because the thing doesn't understand us, because we want something quick and it's not doing it quick. So when you are designing these services, the first thing that you have to do is put the user in the center. What this means is that it's like the 10 commandments, but only 3, so please remember them. The users should be able to speak naturally, natural language, full sentences. We make grammar mistakes when we speak even our own language. That should be understandable by the device. The service shall respond, even if the service doesn't understand us. It should be polite, let's say. Don't frustrate the human. And finally, most of the cases, the intention is that the service does what the human wants. So we need to design the user interface in a way that it's comprehensive and it can pick a lot of the different ways we have as humans to express ourselves. The diagram in the middle was made by Amazon, and what it's saying to us is the utility, so how useful a system is depending on what kind of user interface we use. And it's comparing voice with our eyes, when we use our eyes, visual. So basically, for giving instructions, short instructions, open the door, close the door, get me an Uber, I want pizza, all this kind of thing. Voice is better than visual. Visual, you have to get your smartphone out, you have to find the icon for Pizza Hut, you have to click on it, and what was the option takes longer, whereas if you can just say it, it's better. Pinpointing is when you are inquiring about small fractions, small pieces of information, because as humans, our memory retention when we hear things is not very big, whereas when we see things, we tend to remember more. So at what time does the supermarket close? That's a perfect thing for voice services. For visual as well, as long as your computer or your smartphone can put a big 9, it closes at 9, that it's easy for you to find. And then telling and browsing is when you require richer information, bigger amounts of information, or you need to search, navigate. Then visual is way better than voice. Just bear this in mind when you are defining your systems. In my opinion, there is going to be a brand new job. There will be a full profession, which is voice services user experience. And it's not going to be us, the techies. It's going to be probably the philologists, the sociologists, the neuro experts, people who understand the human mind. Because you will need to create your systems. Probably they will be multi-channel, depending on what you're trying to do. You will render your systems via voice or via other devices, television, laptops, even the fridge, Internet of Things. And you will see now, I will give you a few examples that language experts, human language experts, will have a lot of work in the near future. So, because this is not Amazon-centric, even though I'm using Amazon as a channel, this is a definition of voice interfaces from academia. And so I don't want you to read it, but basically the few concepts that we are going to be touching, the prompts are the stuff that your system can say back. So it's the artificial voice speaking, or if you are doing a chatbot, it's the answers that the chatbot can produce. In terms of in Amazon, this is rendered by Amazon Poly, which is a component of Amazon Lex Services. The grammars is the stuff that we, the humans, can say. So I want milk, get me an Uber, what time is the next Barca match, all these kind of sentences. These would be the grammars. In academia, in Amazon, these are called utterances, things you utter, things you say. And finally, the dialogue logic will be the functionality. So the logic, your system that fulfills what the user wants the system to do. Just bear this in mind because it will be important. And now let's take the DeLorean, let's take the car, and let's go back to the 80s. And this is my youth. First programming language when I was 15 was C. There was some math teacher crazy enough to teach C to high school students in Spain in the 80s. So that was me. In the 80s, don't get me wrong, if you were in high school, there was very little you could do. But if you were at university, we had a lot of things. We had Prolog, we had Lisp, so we had logical programming. We had functional programming. We had object-oriented programming with small talk. We had everything you imagine, probably like the, let's say the core theory of everything we do was already established in the 70s and the 80s. But I can assure you something. The user interfaces, they were terrible. Everything was awful. This was almost the only way that you could interact with users via menus. So you would state your options, and then the user would select an option just by clicking on a number or a key. It was very basic. But when you were a developer, and especially when you were a tester, that was fantastic because there were very few possible combinations, so testing was not automated. There was no Mocha, there was no Chai, unit test. We didn't know what that was, but it was very easy to test because you would just follow the tree, the decision tree, and you would just try all the options. And over here, if you wouldn't type a 1, 2, 3, 4, the system would do nothing. So there was very little you could do in terms of mistakes. And this mimics the way we use voice services because it's menu-based, basically. You have to give the user very few options. Remember, we don't have a lot of memory. Our memory span is very short when we are hearing things. So when you are using Amazon Echo or Google Home or anything else, the thing can only give you very few options. It really looks like this kind of menus. So in this example, I would say that I want option number 2, and then it will do some stuff related to option number 2. And then it will get back to the menu. And this is what voice services do all the time. They kind of keep a little bit of state, but they always go back to the main menu. And this really resonates to guys and girls like me who started to develop in the 80s. So now we would just type a number 1 and some stuff related to number 1. And then I'm so tired that I just want to quit, so I just do 4, okay? So now if we look at the code, and this is where it gets, it's very basic. So this is the way we used to program then. Basically, your main program, your main function would be just printf, 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 and you would just print out all the menu options. Then you would be listening, and if they don't type a number, you just don't do anything. And then once you recognize the option, then you would just invoke a function. The function will do something, and it will return some kind of result, and then you get back to the main menu. This is really exactly the same as with voice services. It really resonates. And that's why I took you in the DeLorean, because I will show you how this program, we will get back to this very simplistic program, how it's really exactly the same. It's the same concepts that I've shown you in the theory definition slide. So now let's get into details, and let's see what Amazon Alexa is. So Alexa skills, a skill is an application or a program that you write that it can be used through Amazon Echo. So that's a skill. And this is the ecosystem. So basically what you have on the left, you will have your devices. So it's the cylinder is the Amazon Echo, but you can also use it via a web browser, or you can just, if you are a maker or you have a maker friend, you can do it with a Raspberry Pi. So that's what you speak to. That thing will record your speech, it will compress it, and it will send it to Amazon for processing. It will process it through Alexa Voice Services, Amazon Web Services. And what is that? It's the red box, which is basically artificial intelligence. That's what it is. So automated speech recognition, natural language understanding, text-to-speech, because this is pretty much the same if it's text or if it's speech. And then it will learn about the way the users speak, like if they have an accent. And then the skills. Skill is another way of saying your application that you write. So Pizza Hut wrote their skill, Uber wrote their skill, etc., etc. The skill is what we do. So how do we do a skill and where do we host it? You have two options. You can self-host it. For instance, you are Pizza Hut and you already have like a booking system. Well, you don't want to write another one. You can just invoke it. You can just plug it to the skill. You don't need to redo it. You only need to comply with very basic rules. It makes sense. You have to comply with an API. So the objects that you pass through need to comply to a certain specification. You need to be able to reach the skill via HTTP in a secure channel on a specific port. And you have to have digital certificate that matches the domain name, so it's not rocket science, very reasonable. And the other thing that you can do is you can host your skill in Amazon Web Services, Lambda functions. If you know about that, is basically a place where you can create your anonymous functions, you can publish them, and then you can invoke them from many places. You can invoke them from your website or from a smartphone application, from wherever. Okay? And this is where I said that you can quickly port your system to another voice services company if you need to. You can just get your skill, work a little bit on it, work a little bit on the interface, and you go to Google if you want to. So again, key concepts, I will go through this very quickly because we have seen it. Skill is your application. Intent is one type of request that the user can give. An example, Uber, get me a car. That would be one intent. Uber, cancel the car. That would be another intent. That's what it is. When you see slot, think variable. And utterance, the words that the user pronounces. So now the decoupling that I mentioned. Disclaimer, I've said it before, I'm a junior, super junior. So when I talk about functionality, don't pay attention to what I say. But this part, I get it working fine. So you have to create the interaction model. That is the user interface. And that is, you have to give your system a name. That is called the invocation name. And you have to define which variables you are going to pass to your service. And that is the slot definition. And you also have to create your sample utterances. And this is tedious, very painful work. And this is the work for the human language experts. So get me a taxi. How many ways can a person get a taxi? Probably 100 different ways. You have to write them all. That's the utterances. And in the middle is the contract between what the user says, how the user expresses a need, and how we are going to fulfill the need of the user. So it's the link between the user interface and the logic of our system. That's called intent schema. I promised that we would get back to this fantastic program. And in terms of voice services, when we're printing out the menu options with our printf, 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 that is what we will call the prompts over here. And then when we would recognize what the user says, is this switch here is where we recognize if they type 1 or they type 2, they type 3, they type 4. But nowadays it gets more complicated because they use sentences, they use voice. And finally, the functionality is totally decoupled. It's at the top. And if you allow me this poetic license, they were almost microservices. Stateless, they just get parameters, they do something, they send it back, and they forget they existed. So programmers from the 80s, I think we're pretty good at voice services. So now, I will not open the console from Amazon, but this is the developer console. So this is a little skill I created. It's called the wine expert. And it's quite fun because you can tell it a wine that you have, like I have a cava at home, and I want to pair it with a kind of food. So you can say, what goes well with cava? And then it will say, cava goes well with pasta, salads, and cakes, for instance. So that's the skill I made, one of them. When you create the skill, the first thing you do is you give some information about the skill. It's multi-language. And it's interesting because you only define your functionality once, but over here it's like you define the two different user interfaces for the two languages. So you give it a name and an invocation name, which is how the user is going to launch your system when they are at home with the device. So it's quite simple, and you have to make sure that nobody else has taken it, and you have to be careful not to use trademarks, etc., etc. So the next one that you do is you have to create the intent schema. And if you remember, the intent schema was the contract between the user interface and the functionality. So over here, what you do is you define what intents you have and what variables you can take. And in my example, it's in the box, So we had as variables possible. There was one that was called custom type name. In reality, it held lists of types of wines and types of food. And the other thing you do is you just give names to the intents. There are two types of intents. Intents you make yourself and intents that are already provided by Amazon Web Services, such as start the intent, kill the intent, yes, no, all these kind of things is already done for you. The slot types are very interesting also for the human language experts, because what these guys are doing, they are creating lists for everything. Amazon is creating these slot types for cities, animals, food types, names of shoes, names of clothes. They are creating like a universal dictionary of absolutely everything in the world in 26 different languages, so that us, for developers, don't have to create a list of slots with the 10,000 different kinds of foods that exist. By the time I did this, they didn't get to the wine list yet, so I had to do it by hand. But typically what you do is you use the lists that Amazon have. And at the bottom is the sample utterances. Now, this is hell, because over here what you have to do is, for each intent, you have to type the way a human being would express it, and then in the curly brackets, you introduce the variable name that they can use, or the slot name as it's known. The way it works with Amazon at the moment is quite crude, meaning that you have to type it in the box, but there is an NPM package with some functionality that helps you dealing with these ones. For this one, what I did, I created a little Access application that would generate the strings because I was so fed up of typing. So the functionality, you have two options. As I said before, you can self-host it, or you can host it in Amazon Web Services as a Lambda function. If you go for the Lambda function, which I recommend, especially at the beginning, you have choice of programming languages. So you can do it in Java, you can do it in Python, or you can do it in Node. I decided Node, not only because I wanted to be here, but because the community was tilting towards Node in voice services. So I wanted to follow the stream. A lot of samples are out there in GitHub. In Node, if you count, the difference to the number of projects that are done in Python is very big. So the endpoint would be there. You can pick if you want your skill to be hosted in America or in Europe. Now, creating the actual skill node. You have like two ways. If you are a rookie like me, or if you are an advanced person, advanced user, advanced developer. I'm an expert on rookie, and I'm working my way in advanced. So first thing that you have to do is you have to code your function. You have to code your functionality, and you do it. We recommend that you use that NPM package. And we also recommend that you use the samples at the beginning especially. You can do wonderful things like turning a Minecraft recipe into a wine food pairing. You can do it, so just use the examples. So you have to do both in both tracks. Then what happens when you are a rookie is that once you are happy with your code and you're totally blind and you didn't test anything, you just upload it. And then you just log on to the developer console, and then you just test it. And then it's broken, and you get endpoint not reached, and many crazy messages. And then you just get back, and you do the loop until you are happy. When you are in advanced mode, what you can do is you can install your Alexa server on your machine, and you can do your unit testing, and you can do mocks, and you can do whatever you need to do. So you can develop professionally. Once you are happy with that, you can even deploy directly from Git. Again, this is the only option when you use Google Home. Amazon lets you do it by hand, and that's why I chose it. And then you have to submit your skill for certification. To certify your skill, my recommendation is that you, even if you did your testing professionally, you do manual testing on the console, because this is what Amazon is using to certify your skill, and you should make sure that it works. And then you submit for certification. There is a service simulator. So this is the testing console. So basically what you would do is you would be like a user. You would type something. You type it. and then you just press enter, and then on the left, you see the request that you have generated, the JSON object that you generate, and then you get to see the Lambda response. Once you do that, it looks like this. With the Lambda response, this is very cool. You click on listen, and then you get the Alexa voice saying it, and then you can recognize, or you can see how the user is going to experience it. Sometimes you have to play, you have to introduce seconds, you have to give some intonation to break the, let's say, the machine feeling of Alexa. When you certify, there is like a life cycle over there. I will only say two things. It takes about 2 days for them to get back to you. They are very reasonable. They typically say yes unless it's really broken or you are using trademark names. And during those 2 days, your skill is frozen. You cannot touch it. So it's the only thing. Chatbox. So we abandoned voice. We still are with natural language, but now we are in chatbots, which is something that you can also try out with them. It's very similar. In fact, they use Lex, and Lex is the heart of Alexa, so you just get Alexa, get rid of the 2 A's, and you get Lex in the middle. Only that the way you render the chatbot is not via voice, it's via text, and you can embed your chatbot on Facebook, on Twilio for SMS, or on Slack, which is the newest addition of about a month ago. I believe that very soon you will be able to embed it on a website, so you will be able to generate a bit of JavaScript, you put it on your HTML, and there you go. And I also believe that everything I have explained about Alexa skills is version 1.0. It's going to be refactored so that it works through this channel. I think it's the first iteration, but chatbots and voice services are going to merge. The concepts are very similar. The only difference is that here you have a channel, so a bot, you can publish it on Facebook and on Slack, and probably on your web page as well soon. The rest is exactly the same, only that instead of talking about skills, they talk about code hooks. And the console, it's not the developer console, it's the Amazon Web Services console. It looks a little bit different, but it's pretty much the same. You define your intents and your slot types, which are your the actions that the user, the options that your system offers to the user, and the variables. You just create them. Then this is generic settings, your IAM, which is quite complicated to get right, so use the samples. The channels, in my case, I managed to publish a chatbot on Facebook, and 15 minutes of reading documentation, so not too difficult. And the intent. In the intent, it's again exactly the same as before. You define the sample utterances, but instead of being a long list, you just do it one by one, and you define your slots. And you use Amazon slot types with all the cities in the world and all the food in the world, et cetera, et cetera. And then the intent is just matches the utterances, the variables, and then you tell it where the code or the functionality is hosted. So basically, I told you I'm a dummy, so don't listen to me when it comes to code, but your system or the Lambda function you need to create will receive one of these babies from the left. It will have to do the logic, and it will have to return one of these ones. So that's very clear, disentanglement lines. Testing the bots. So it looks like this. Service machine. This is very specific to my company. So it's a request. Didn't understand it. So I want an appointment. This is what I wanted. So what is your name? It's Eva. Over here, a little bit of natural language processing. My name is not it's Eva. My name is only Eva. Again, the day after tomorrow and midday. So it's picked up that my name is Eva, that was the date when I copied this screen, and that midday means 12. And it will just generate the request to the skill, and it will just say something back. So it's quite easy to do. It's quite easy to publish on Facebook. And finally, because it's been a little bit longer than I expected, If you want to do the same, but it's funnier, just watch this movie because don't pay attention to the story. The story is a little bit stupid. But the way these guys use technology, this is like in the near future, it's amazing, and I think this is the way we are going. So we are going to talk to our technology, which is like in our pocket. We don't get it out of the pocket, and it will understand it better than our partners. So this is me. I work in a big industrial gases company. So that's what I do during the day. And in my free time, I blog, I travel, I try to do techie things. I tweet a lot. Mind you, if you follow me, you may need to mute me because I tweet a lot, and that is my blog. So just to finalize this, food for thought. Would you adopt a vintage developer like me for your team? Reverse mentoring is a thing nowadays. Mentoring used to be the senior guy in the company that looks after the junior guy in the company, but nowadays it's the opposite. The senior guy in the company has no idea how the world works and wants the junior guy in the company to teach him how the world works. So that's reverse mentoring. And if you want to discuss that, would you be able to take a 40-something person in your developer team? Thank you.